Hello friends, welcome to my webinar on Defect Lifecycle Management, and I am your host Prashant Kumar. So friends, let's begin with our today's webinar and let's move on to today's webinar's agenda. So for agenda, we have these points which are going to be covered in today's webinar. What is a defect? How dangerous a defect can be? We'll see what is the impact of defect and how dangerous a defect can be. What is defect management? What are the different kind of defect management techniques? We'll see defect reporting techniques and we'll get to know about it. And finally, last but not the least, I'll share a few QA best practices in terms of defect lifecycle management. Okay, friends? So let's please move on to our webinar slides. I'm going on to our first slide. We have what is a defect? So friends, if you go ahead and type the word defect and try to search the meaning of defect, literal meaning of defect on any of the search engines, this is what you will get on your screen. You'll get something, a definition of defect. It's a noun which means a shortcoming, imperfection, or lack. It can be a flaw, fault, imperfection, deficiency, weakness, inadequacy, shortcoming, limitation, something which is failing you, obstruction. This is what is the meaning of defect, literal meaning of defect. But in terms of software quality, whenever we have an actual behavior which is not meeting with the expected behavior. So whenever we have a difference in actual versus expected behavior, then we call it as defect, bug, issue, or incident. So in terms of software testing, whenever we have an actual behavior of a software which is not matching to the expected behavior, we call it as a defect, bug, issue, or incident. With this, we move on to this next slide, and it will show you why are we talking of defects. It's a comic strip, and whenever I see such kind of a strip, it really makes me laugh. You can see we have a software manager and a service provider, and he's saying, the manager is saying, okay, software manager is saying, we found a dozen of bugs in the software you sold us. And see, the service provider who provided the software provider says, we can fix those bugs. We can fix these bugs for $20,000. What? But obvious, if somebody's asking, you bought something and then it is still having issues, you'll have the same kind of reaction. And then the guy is saying, put more bugs in the software, I'm making fortune out here. Yes, my friends. Software bugs are not always harmful. In certain cases, they can be beneficial for you as well, as you can see for this guy. And then we have this team who is talking about quality. Remember, quality is our top priority. So sometimes eliminating defect brings you the quality, and sometimes introducing defects brings you the quality. Okay, now this was just for fun. Please don't follow it blindly. Now let's move on to our next slide, which talks about how dangerous a bug can be. Yes, friends, this is a question which is being asked to me so many times. People, they keep on asking, okay, this is a bug, something which is expected to work the way it is expected, and it is not working. There's a deviation, and okay, there's a bug. But what do you think? How dangerous a bug can be? Now, this question is a very important question. Software failures due to bug or defect can be potentially causing huge financial or human losses. Yes, in past we have seen there are so many incidents in which any software failure has resulted into a huge kind of financial or human loss. History is full of such kind of incidents. Let's discuss it with a few real-time examples. So in coming slides, I'll show you two live real-time examples which are very much prominent and evident in today's world. Okay, friends? So let's move on to our next slide to see those examples. Okay, transaction failures. All of us who are into software industry or even a layman who is depositing money, he is very much aware of the word transaction. If not this in terms of software, then in terms of the business, they must be aware of this term transaction. Whenever you deposit or you take out money or you do certain kind of banking related activity, it results into something which is known as a business transaction. And now, may it be cash or cashless economy, or may it be bank wire transfers, or today in this world we have seen cryptocurrencies coming into picture like Bitcoin, Ethereum, all these cryptocurrencies, they are so much into market and they are ruling market, they're growing like anything. All of this, they require to register a kind of transaction. They need to have a kind of transaction, and that is the way you can either buy it, sell it, or update it, or send it to somebody, or receive it from someone. This is the way you can do it. If at all there is a transaction failure in software because of the software bug, if there is a transaction failure, then just imagine you have your salary account in a bank and something goes wrong and your salary is not being credited. It's so traumatic, right? Or you send out money to somebody, they are in need and they're not receiving it because there's some software bug and the transaction cannot be reported. And we have seen many incidents regarding cryptocurrencies where people, they forgot some of their password or somehow they mess up with their password, or the way they are transitioning, they mess up in the process. Because of that, they lose huge amount of money and it can never be recovered back because transaction, there was some kind of issue or bugs in the transaction and it resulted into a transaction failure. So this is something which is an example of monetary loss or financial loss because of the software bugs. And the next one is, this is a very sad one. This is an aeroplane crash. Yes, Air China flight crashed in year 1994, killing 264 passengers on board. And the cause was malfunctioning of autopilot system. Yes, friends. All of us, someday or the other, might have traveled in flights, and we are very much aware of autopilot system of the flight. So Air China flight, it crashed down because the software for autopilot system was malfunctioning because of a bug in it. So these are just two examples to prove any kind of bug may end up into a huge financial and human loss. With this, we come to our next point, which is very important one, and that is the backbone of our today's webinar. This is what we are going to discuss today. What is defect management? Now we know what is a defect and what impact a defect can have on human life or on his economy or on our society. We are well aware of it. So if we know defects are so dangerous or it can lead to certain kind of problems like this, what exactly we should do? We should manage those defects. And to manage those defects, we have to use this technique, we have to use these steps, we have to use this process, which I'm going to list in front of you. The first step in defect management is to discovery of the defect. You have to identify where exactly is the problem, what we are supposed to see and what is happening. If at all there is any discrepancy, which I said expected versus actual, if at all there is a difference in expected versus actual behavior, then there is a defect. You have to discover it and then you have to categorize it. When I say categorize, people who are coming from the software industry, they very well know software categorization is done on the criticality and severity basis. But nowadays, once we are moving into agile environment, there is standard terms, critical and severity, more or less they are same. High, medium, and low, or criticality, very critical, low critical, and moderately critical. All these things, priority and criticality, more or less, they are synonym to each other in today's software IT industry. So depending on that, what exactly is criticality, and then we move on to the resolution. The third step is resolution, where we figure out how exactly we can solve this problem, that issue, that defect, that bug. Once that resolution is being done, it is to be verified, means retested. Here is what is testing being done. So when you discover that point of time, testing is done, and then you figure out what is the issue. Once you have the resolution, you again test it and you figure out, okay, whether this issue has been fixed or not. After the verification, you mark it as closed, you provide the exact new version and check it with users that yes, it is fixed, and you mark it as closed, and then you report it back that it has been done, everything looks okay. And in this way, a complete cycle of defect management is completed. Now, just in the last slide, we talked about defect categorization. Defect categorization can be on priority or severity basis, which I said nowadays in the agile test environment, priority and severity. Earlier in traditional testing environment, priority and severity used to be two different things, but now more or less they are same. So let's go and figure out what is a critical, which is a high, and which is medium and low priority or severity bugs or defects. The critical ones are those defects that need to be fixed immediately. If you don't fix it, the whole system may crash, and it can cause a great damage to the product. So those defects which are very important and which may end up into crashing of the whole system are known as critical. The next to it is the defect impact of the product's main feature. If we have a defect which is causing impact on the product main features, it is known as a high severity. And then if the defect causes a minimal deviation from the product requirement, like expected versus actual result are not matching to minimal level, then we call it as medium. And if it is a very minor one and it is affecting product operation on a very smaller extent, so we call it as low. I'll give you an example of critical, high, medium, and low. For example, if we have a user, and as soon as the user is trying to log in the system and he's clicking on enter button, the system is crashing. The login is failed and he's redirected. User has to log in again. If something like this is happening, that is a critical issue. For example, login is working fine with mouse enter, but as soon as you click on enter, you type the login password tab and then enter, the login is failed and user cannot log into the system. Let's say online banking system. Such kind of issue is a critical issue and it has to be fixed at an immediate basis. Now, the defect impact the product main features. Now, if user has logged in and after logging in, user is working on different modules, he's checking his balance, and after checking the balance, user is trying to take a printout, and as soon as he clicks on print, the signal is gone, but no printer connection is somehow failed and no printout is performed. User is not getting a printout. Every time an user is sending print, printer is connected, everything is working fine, and it is not giving you the printout because signals from your banking system is not being received by the printer. Somehow the signals are not complete. It is getting broken somewhere, and it is not being handled. So this kind of defect can be a high priority defect which needs to be resolved. Medium priority. Let's say in the same banking system, we have something like user has defect, something like he is adding some values, and those values, let's say he's sending some money to other bank account, and as soon as he's sending the value to some other bank account, he's shown a transaction number, and that transaction number is not stored in the system for some point of time, and it comes in the system after a little bit delay, with a little bit delay. So this may cause panic in some of the users, and they may get, what happened? I transferred the money and I saw the success message, but somehow the transaction number was not being shown. What happened? There's a flash and it is gone. But after some time, when they log in again, they can see it because the transaction was successful and everything was stored. So it is just a UI representation, but since the time duration for which it is happening, it is coming with a flash, it may cause a kind of ambiguous kind of feeling inside the user's mind. So this is a something which can be resolved, but yeah, it is a medium priority thing. And the low priority, let's say all the text which are shown to user, they are in normal font. Instead, if when a user is changing the last balance which is shown to user, it should be highlighted one, maybe in bold or maybe with some color. So this is a low priority, a very minor issue which should be reported, which should be fixed. Because in any case, user can see the balance and it is shown correctly, value is correct, but it's only the representation, UI representation. Instead of bold, it is being shown as a normal one. Okay, so this is the example of defect categorization: critical, high, medium, and low. Now, I was talking about defect categorization on the basis of criticality because I wanted to talk about the risk and impact in this slide. Risk is the failure risk, which I'm talking about. System risk, which is I'm talking about, is risk of failure, and likelihood is the probability of failure, and impact, okay, high, medium, low, how critical it is, this is the impact. So we might be having a set of test suits, let's say maybe 10,000 test cases, which we have to execute as a part of our regression. Or maybe we are developing a system and we have a number of test cases which we have to execute so as to ensure that the coverage is complete and all the test cases are done. But what if you have a small amount of time and you have some important features to cover? What should you do? In that case, you have to come up with the approach which is known as risk-based testing. You have to divide the whole system into three parts: high risk, moderate risk, and low risk. And how we do that? We have a matrix, we create a matrix depending upon the likelihood of the failure and the impact of the test cases or the functionality. If they are failing, what will happen? So you can see we have red, yellow, and green section. Green is the one which is a low impact and low probability of failure test cases. The medium one is moderate impact and moderate likelihood, and red is the high impact and high likelihood of failure. So as soon as you have a system in place which is ready to be tested, first of all, this red section, all those functionalities, all those test cases which are falling under this red area, they should be tested at first, and then the one which is in yellow section should be tested, and at last, depending upon your bandwidth and your execution time and effort, whatever you have, or the resources you have, you can go ahead and perform testing for this green area, which is of the least priority and least likelihood of failure. In this way, we can ensure that the high risk items are already tested and we don't see any defects, or the critical defects are eliminated. And how exactly we do it? We do it in few stages. The first stage is assess the risk. First of all, they assess the risk, create this diagram. Depending upon that, you figure out high, moderate, and low areas which have to be tested, and then design the risk matrix. I just now described the risk matrix, and then decide the test target. Depending upon your cost, effort, resources, and budget, you can decide which area to cover first. If I have a minimum set of resources to be used, then I'll just cover the risk high risk area. If I have some more resources, I'll go for the moderate, and if I have little more, I'll go for the low as well. Expand your test coverage. Yes, start from the high risk and high likelihood and high impact area first, and then keep on growing to moderate and to low. You can trade off depending upon the time, whatever time you have, whatever cost you can spend on your testing, and whatever resources you have, depending on that. Quality versus speed versus time versus cost, whatever you have, you can trade off, and you can figure out which approach to choose. Innovate. Yes, innovation is a very important technique to be used. Like if you can automate, if you can use macros, if you can use some data-driven testing, if you can use some kind of performance testing or whatever it is, some way so that in minimum effort you can have the maximum output. And last, learn from the mistakes. Whenever you create a mistake, you cannot be 100% perfect right from the day one. Depending upon your learnings, every project has its own set of environment and resources and a skill set. So as you start working into it, depending upon your skill set, depending upon your learnings, learning from your mistake, you keep on improving. So with those improvements, you'll surely do better in future. Reasons for defect. Now we talked so much about defects. What are the main reasons which causes such kind of defects? Unfinished requirements, if the requirement is unfinished, or if there are not a detailed time requirement are not detailed enough, or requirement with unclear or multiple requirement, or in case if we have something like logical errors in design documents, coding errors, not enough or sufficient testing being performed, misunderstanding of user needs, lack of documentation. So something like lack of documentation can also cause defects. So these are the main reasons because of which user can see issues. Defect management benefits. There are a lot of benefits of defect management. Few of them are increased visibility of development process, release planning, resource scheduling, prioritization, improve control of a project, information consolidation, improve the quality of software, and cost impact. So let me explain these points. Defect management benefits will include increased visibility of the development process. If a user is knowing about the kind of defect which he is seeing or he may see, it will increase the visibility of the development process. It helps in the release planning. You know what are the issues you have to fix, so it helps you in the release planning. By knowing the issues which you have or which you'll face, you can plan your resources well. It helps you in prioritization, which are the high criticality, low criticality, medium criticality issues. You can prioritize them. It gives you a higher control over the project. Since you have control over the resource, you have control over the effort, you have control over the task which you're going to do. It gives the improved control over the project. Information consolidation. Now you know all the good, bad scenarios, best case scenarios, and worst case scenarios which need to be covered. So you have an information consolidation. And it improves the quality of software. Indeed, it improves the quality of software, because by removing all these defects, you're creating a high quality software for your users. And last but not the least, cost impact. We know this 80-20 rule, which is very common. And all of us who are from software industry, we might have heard this term so many times. 80% of the cost of a software development project is due to 20% of the defects which are causing in the last phase. So if we can figure out bugs in the early stage, the cost of development of software will decrease a lot, because maintenance or bug fixing cost will be reduced. If we are finding bugs early, it will be resolved early, and hence a high quality product will be delivered. It will be good for our industry, it will be good for our customers. At the same time, it will be good for us because it will lower down the cost. Now I'll talk about few defect management techniques. Defect management techniques are as prevent the defects. You might be thinking, if it is not possible, then what? Yeah, we cannot 100% guarantee that we are preventing each and every defect. If it is not possible, the defect should be found as quickly as possible in order to minimize the impact of the defect. The process should be risk-driven. That is, the priorities and the resources should be based on the extent to which risk can possibly be reduced. The bugs measurement should be integral part of the software. The bug measurement should be integral part of the software development process and to be used by the project team to improve the process. Depending on the bugs you get, depending on the defects you get, you should measure it, and then on those lines you should figure out where is the software development process going and how your team can improve. The process of reporting and analyzing the bug related information should be automated as much as possible. Yes, reporting and analysis of bugs, wherever you get a chance, you should try to automate it. This will help you in effective defect management. So these are the few basic defect management techniques. Now let's talk about the defect reporting techniques. These are the few important uh, points or few important factors which we need to keep in our mind before we are reporting any defect. First of all, we should have an ID which should help to identify the defect in a unique way. Many of the defect management tools like QC or Jira, they help you generating a unique identification numbers. You should maintain the project for which you are testing, the product which you are testing, release version of the candidate which is under testing, which you have been testing, module, a specific module or product where the defect was found, detected build or version, where the build version of the product where the defect was detected, and then the exact summary to keep it concise. And just by reading the summary, the developer or the business user should understand what exactly is the issue. And then you should provide the detailed description and talk about as much as possible, which will help the user or the developer to replicate the issue in their environment. It should be simple but comprehensive. The steps to replicate is a very important thing. You should provide in this step to replicate, because if a defect is non-reproducible, it is of no use. Trust me. It is of no use if your users or developers cannot reproduce it, else how will they fix it? Actual result, what is the actual result you see and what is the expected result? So difference in the actual versus actual, this is known as defect. That's what we are mentioning over here. You should provide it all kind of attachments such as screenshots, error log, or any kind of UI, whatever you are seeing as a part of defect. Provide your remarks, any question which you want to ask, and then you should talk about defect severity or priority. I assume in today's agile environment, it can be same. So if it's up to you, I'll leave it up to you. Reported by who is reporting it, and assigned to the development team or the business team to whom you are assigning, what is the current status. And once you have this, you'll go ahead and check it on the fixed build version to make sure that on which version it was fixed. So these are few of the most important points which you have to keep in your mind when you are reporting a defect. Now, with this, we come to the end of our slide, which talks about QA best practices. Yes, friends, we have been talking about defects, we have been talking about defect management techniques, we have been talking about different aspects of defects, benefits, but to have all these things, a QA has to come up with a lot of new, innovative, and different kind of best practices. These are few best practices which I have learned in last 12 years of my testing or software development career. So I'm just mentioning it. It's up to you. If you want, you can use all of them, or you can use selectively few of them, or maybe you can come up with your own best practices. So to start up, keep an eye on the bigger picture, that is the user experience. Always have, while you're testing, always have an eye on the bigger picture. What exactly a user is trying to achieve? What is the goal of this process? Always have a bigger picture in your mind. This helps you to understand the whole workflow. And then adopt a technical mindset with business value. A complete business value mindset or complete technical mindset, it's not a very successful approach. In current market, you need to have a technical mindset. You should figure out, okay, from development side, from support side, from testing side, what are the different kind of approach, what is happening, what is the issue, how to debug it, how to resolve it, what is the exact root cause of the problem, and then you have to relate with the business value. Okay, this is the kind, for example, you're putting a lot of effort, technical effort, but then its business value is low. So there's no point going ahead putting so much of business effort on so much of technical effort on something which is having a low business value. So you have to understand the technical details. At the same time, you should be aware of the business value. And then build a credibility with your business stakeholders. When you test, I believe, in fact, I believe testers are somebody who are the closest one to the business users. They do more or less what a business user does. So if you're finding an issue before a business user itself, means you're replicating a business user, and it is very much important. For example, you test a issue, you test a product, and then you pass it, you sign it off, and when your business users, they are using it, they figure out some basic problems, which as per them is a critical, but you couldn't identify the tester, then it is going to bring you a bad name of bad credibility. So always try to build up a credibility by finding business related issues, and this will help you to have a great rapport with the business stakeholders. And this is the important one. Never assume, always ask. May it be new, may it be old, rookie, or expert tester. This is my advice to all of them. Never assume. Always ask questions. Even at this point of time, whenever I'm doing some testing, sometimes I don't understand things. Instead of assuming, I go ahead and ask. Or even if I assume, I go ahead and ask question to the business stakeholders, business analysts, consultants, or to managers or directors, just to make sure or confirm that my understanding is true. I never go ahead blindly by assuming anything or by my assumption. It's always okay to act like a fool and ask questions. There's nothing wrong in it. And test often, test early. Yes. Don't wait. I have seen in past people used to wait and do a lot of planning, and then they used to get a build, and then they go ahead and test it, and then again and again fixes and sign off. That era has passed. It is gone. Now we have to think of a different approach where we have to test very often, test often, and test early. As soon as you get in a build, okay, if the whole system is not ready, a little functionality or modularity, just go ahead and test it. Do some kind of exploratory testing, smoke testing, just verify. Run a small sample of code, do black box testing, white box testing. Just figure out any way to test often and test early. And last but not the least, keep learning. Learning should be the most important thing which all of us should do at all point of time. And in fact, that's the reason I'm sharing my learning with you, because with this, whatever I have learned, I can share it with you. And at the same time, with your comments, with your comments and with your likes, with your feedback, I also get to learn. This is very important. Please keep learning, as I learn so much from what you people share with me. And in the same way, I love to share my learnings with you. Last but not the least, as per me, testers are superheroes. Yes, with great power comes great responsibility. You know, there's a Spider-Man quote, right? Exactly. So every time I go ahead, I sit on my system, I sit over there and start testing my system, testing some functionality. I feel like, okay, I'm a superhero. I have the power to build or destroy anything. If I say it is pass, it's pass. If I say fail, then it's fail. So testers are superheroes as per me. And this is me. Thank you, friends. You know me via LinkedIn. Please feel free to like, share, and subscribe. Thank you.